So on the first one here, formula for circumference. How do you find circumference?
Pi times radius.
Okay, pi times the diameter, or 2 pi times the radius.
How do you find the radius?
Okay, radius is half of the diameter.
No, like, not everyone.
We'll do some problems like that in just a second. Okay, so on this first one, just simple look for the circumference. So that 12.3, is that the diameter or radius?
Radius.
That's the radius, obviously, so we're going to go 2 pi times 12.3.
Hey, Mr. Moon. I don't think it's on your screen.
Okay, 77.28 yards.
Or do you run it?
TT.
Yeah, we're just going to do it like that. Okay, so I'm going to skip the next one. I mean, that's simple. All right, next one, we're given the circumference. We're looking for the diameter and radius. I'm going to find the diameter first and then get the radius from that. So if we know the circumference, how do we get the diameter? Yeah, just divide by pi. So we're going to do 29.45 divided by pi. And what does that give you?
9.37.
9.37 inches. Now from the diameter, how do we get to the radius?
Divide by 2.
Yeah, just divide by 2. So we're going to do 9.37 divided by 2.
4.69.
Okay. 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 The next one is asking for the arc length. So arc length is the distance from here to here. It's not the degree measurement, it's the actual length. So here's the formula. 2 pi r times m over 360. 2 pi r times m over 360. R is the length of the radius. M is the measurement of the angle, the central angle, or the measurement of the arc, which is going to be the same number. You'll see. Okay, so it's 2 pi times, how long is the radius of this one? 3 times what's the measurement of that angle? 80, because I'm looking for this arc AB from here to here over 360. So 2 pi times 3 times 80 over 360. Okay, what does that give you? 4.19 feet. All right, number 6, exact same thing. I'm not going to work another problem like that. You got it. Okay, on this one, okay, the first thing I need to do is figure out what is the full length of the radius on this circle A.
30.
Okay, good. It's 24 plus 6, so the radius of this circle is 30 units. So any radius that I draw on the circle, because what I'm looking for is the length of DE right here. That's eventually what I'm headed towards. Any radius that I draw is going to be 30. So where do you think the most convenient radius would be to draw here? A to E. Okay, so that's 30 units long. All right, and so what we did here is we created this right triangle. So we're going to use what to find the length of this side down here? Good. Pythagorean theorem. So I'm going to go 30 squared minus 24 squared square rooted. And that gives you 18. So that's just from here to here, which the way this works, that's going to be 18 from here to here. So good. I'm going to add 18 and 18 to get a total of 36 units. Okay, on the back. All right, central angles is the top one here. So if this central angle is 98 degrees, how many degrees is this arc?
98.
It's 98. The central angle and its arc are always congruent. So on number 5, what's the measurement of that arc? It is 149. Okay, so that's very easy. Okay, on this one, what's the measurement of that arc?
110.
It was 110, nothing to that. Okay, and that's the answer to it. So, but I want to do one extra thing with this circle here. I want to find the measurement of this angle. How many total degrees is there in a circle? 360. So if I want to find the measurement of that, what do I need to do?
Subtract it by 360.
Yep, just do 360 minus those two. And that tells you that this angle, which means this arc also is going to be 130. So those are what we call central angles. Angles where the vertex of the angle is the actual center of the circle. The next type of angles that we talked about in this unit was inscribed angles. So remember, an inscribed angle is where the angle, the vertex of the angle is actually on the edge of the circle. So like on this one, let's say that arc LM is 100 degrees. How do you get from the arc to the inscribed angle?
Divided by 2.
Yeah, just divide it by 2. So what would the inscribed angle be there?
50.
It'd be 50. So on this one, I'm looking for this inscribed angle. I've got to do one thing before I get there. I need to find the measurement of this arc YX. How am I going to find the measurement of that arc?
Add the subtract from 360.
Good. So I'm going to go 360 minus 110, bless you, minus 146. What does that give you?
104.
Is 104. So this arc is 104 degrees. So how am I going to find that angle down there?
Divided by 2.
Divide it by 2 to get down to here. It's going to be 52. Okay, on this next one, this is not necessarily related to that inscribed angle. It's just, okay, this chord and this chord are congruent because it says they're both 14. So if those two chords are congruent, what do I know about this arc and this arc right here? They're congruent also. So to find the value of x, we're just going to set them equal, solve for x. X plus 17 equals 4x plus 2. Minus x on both sides, 17 equals 3x plus 2. Minus 2, 15 equals 3x, divided by 3. And x equals 5. Okay, next one. So this arc from J to N, let's say this is x degrees. And let's say the arc from K to M is y degrees. And I'm looking for this angle right here. Okay, so this is just the general one. How do we find that angle? Okay, yeah, on this one it's x minus y divided by 2 gives us that angle. X minus y divided by 2 gives us the angle. So this is a specific example of that. This arc from here to here is 113. This arc from here to here is 23. So we're going to go 113 minus 23 divided by 2. And that's going to tell me how big that angle is.
45.
It's going to be 45 degrees. All right. On this one, all right, from here to here, let's say this is A, and from here to here, let's say this is B. From here to here, this is C, and from here to here, we'll say this is D. So remember how that one gets set up.
AB
A times B.
A times B.
Good. A times B equals C times D. A times B equals C times D. So on this one, we're going to do the same thing. And this is a specific case of it. So how are we going to set this one up?
5 times 12 equals x times 2.
Good. 5 times 12 is going to equal x times 10. So 60 equals 10x. Divide both sides by 10. And then x equals 6. Okay, then on this last one. So on this, let's say this is x from here to here. Let's say it's y from here to here. And let's say it's z from here to here. So first of all, I want to write like this. The whole times the outside equals a tangent piece squared. So how long is this whole segment from here to here?
X plus 7.
X plus y.
Is x plus y times how long is the outside piece? X equals how long is the tangent piece? Z. So that's just the general form of it. All right, so I'm gonna do the same thing on this one. Okay, whole times outside is gonna equal the tangent piece squared. So how long is this whole line segment right here?
X plus 7
X plus
times
7.
X.
Okay, times how long is the outside piece? Is X, right? The outside piece on that line segment is X. Equal, how long is the tangent piece? 9, so 9 squared. So what are we going to do on this side over here?
Distribute.
Distribute.
So in questions like, so remember how we,
Yes.
in other situations to find x, did we, never mind.
Yeah, I mean, we're about to get into that exact thing right here.
No, I already realized the answer to my question, I'm sorry.
Okay, so we got to distribute. What's X times X?
X squared,
X squared. What's X times 7?
7x,
7X and 9 squared,
81.
81. Now, are we going to be able to cancel out the square here?
No.
Nope. Are we going to be able to cancel out this X?
No.
Now, there's nothing else that's going to be able to combine with it to just get rid of it. So this is actually a quadratic function. So what do I need to do here?
Subtract 81.
Yep, subtract 81 on both sides. And then that way it'll allow us to basically do the trick of graphing it and seeing where it crosses. So what I'm going to do now is go in my calculator, graph that, and let's see where it crosses the x-axis.
16.
How do you graph it again? I forgot.
You just put it in.
I know, but how do you like find them?
You press
It's the
menu
menu
6
six one.
one.
So if you graph it, you'll see it's like 1, 2, 3, 4, 5, 6, something like that. Yeah, I got messed up, but it crosses just a little bit more than 6.
6.62.
Yep. And so if you go in and you in your Inspire, if you use the menu 6.1, it'll find the zeros, and you'll see that it crosses here at 6.16, which it crosses over here also, but really in this context, I'm just worried about the positive value of it. So x equals 6.16 on that one.